Okay, so we've talked a lot about the Rust programming language at this meetup. We've gone through the book, and we've done other talks on Rust itself, but we really haven't talked much about the ecosystem of Rust in any great detail. And I think half of learning a new language is the language itself, but the other half is all the libraries and community that comes with the language. And so I want to make a little presentation, a little start about more about the libraries, which we call crates in Rust. And so I've chosen a bunch of crates that I'm going to just go over. But first of all, let's talk about who am I? Well, my name is Matt Davies, as you can probably see from the name on Zoom. And I've been coding video games for over 25 years. I'm a Rust enthusiast. And because I've been programming video games for over 25 years, I'm a hater of C++. I really detest C++. I thank the heavens for Rust. Allow me to do more interesting things in my spare time. So I got a bit of contact info here. You can contact me at badcode@proton.me. That's a 0 in the code. Some of the programmers of you will recognize that as hexadecimal. That's why I chose it. I think it's appropriate for some of my hobby projects as well. I don't use Twitter for the obvious Elon Musk related reasons. So I've been checking out Mastodon, and I chose mast.to because it's the shortest URL I can find, because I'm a lazy typer. And you can find me there. So what is it talking about? I want to raise the awareness of some of the simple crates in the ecosystem. And I will provide some overviews and some code samples. I won't go into really deep detail because one crate could fill up an entire talk quite easily by doing that. But I do want you to be aware of what those crates are and what they can do. And if you need to find any more details, I really encourage you to read the full documentation of each of those crates or any other crates at docs.rs. So let's go on the first one. Oh no, I needed to say one more thing. So I did a talk before with this meetup, and it was writing a image viewer from scratch. You can find that video on YouTube at this address, and the source code at that GitLab address. So I won't be covering the crates at all in that talk because I used them and went over them in some detail in that talk. So that's clap, which does command line interfaces for command line tools. Image, which can load any kind of image, JPEGs, PNG files, GIFs, whatever. Pixels is a simple frame buffer rendering crate, so I can get pixels on the screen. This error is a way to define errors in Rust and create structures that automatically define the error trait. And when it is for opening a window on all platforms and providing a handle for other crates to use, such as pixels. Okay, so crate number 1 is log. This provides a set of standard macros for creating log messages really easily at different levels of urgency. It doesn't actually produce any logs. This crate is used as an interface to other crates that actually do the implementation of the logging. It's very simple. We got a bunch of macros, trace, debug, info, warn, and error. Now, I'm not sure what the difference between trace and debug is. To me, they're the same thing. But you use info normally for just announcing certain events in your application. Warn for things that aren't quite right. Error for highlighting things where errors occurs that can't be recovered from. And you'll get a kind of output like this in nice color coding right there. But you won't get that output from log crate. To get that kind of output, you need the next crate I'm going to talk about. And that is env_logging. This provides an implementation for the log crate. So if you call env_logging init, then all those log macros will then use this to actually output those messages to standard error. And the reason why it's called env-login is because it uses environment variables to set the login level. And initially, by default, no messages are shown at all. But you can change that by setting the minimum level of login you want. And so if you want all the messages you can possibly have in app, you will set the debug level to, the login level to trace. But if trace and say or debug, for example, are just too verbose for you, then you can set it up to say info, and you will only see some more important messages. So on Windows, because Windows is crap, you have to set the environment variable separate using the set command, and then you just run cargo. Unix flavors a bit more sane with their command line interface, and you just prefix any environment variables when you start cargo like so. There are other log implementers. There's a ton of them. A few that I found is one called Simple Logger. It's kind of like env-logger, but you're able to set the actual level you send the messages in actually programmatically within the init core. There's a pretty env-logger, which is pretty much env-logger with more colors, and flexi-logger, which gives you a lot more control, such as output to files. Okay, crate 3, Chrono. Now, Chrono provides date and time functionality, supports time zones. It provides duration and timestamp types, and provides formatting options, including ISO standards. By formatting options, I mean when you want to generate a string that describes the time or the date or both. There are various ways you can do so. So here's a quick example. So for duration, you use the duration type, and there's a bunch of methods on that, static methods that allow you to choose. You can set the type duration in seconds, milliseconds, etc., etc. And you can do conversions as well by various methods once you've created the time. So, for example, I've set it for 5 seconds there, and I've asked it for milliseconds. You can do local time as well. If you use UTC, that basically is the universal time, and that's essentially the time based on GMT. Essentially what you want to do is to take any sort of local time and then convert it to UTC time before you do any sort of processing. And if you want to present the time back, you will usually convert UTC time back to the time zone that your user is in. Local time does include the time zone information from your operating system, and I've also added some code there to just demonstrate how you would format the time into a string. So here I decided to use the full year, month, date, and hours, minutes, and seconds. And there you can see the output of that bit of code down the bottom there. Okay, crate 4, UUID. I use this an awful lot. And if you don't know what a UUID is, it basically stands for Universally Unique Identifier. And essentially, it's a string that's generated that is unique across time and space. When you generate a UUID, that UUID is almost guaranteed to never be able to generate it ever again on any machine, anywhere in the world at any time. So it's great for persisting IDs that may last years. And UUID can generate and parse IDs. So you can provide it strings, and it will parse that and then create the UUID type from that. And it also has some methods to actually generate those strings in various formats, because there are several formats for representing UUIDs. You know, why have one format when you can have multiple, hey? So some code that demonstrates what UUID do. So in the first couple of lines, I'm using new v4 to generate UUID, and you'll need the v4 feature switched on for this crate for it to have that function. And v4 is essentially what you want to use most of the time, and you got some very specific reasons. Those reasons are explained in the documentation, so I recommend you do read that documentation. And if we print it out, basically you're going to get a UUID string, which is essentially hex, 16 bytes of hex, but formatted in a very specific way with a very specific placement of hyphens between those hexes. We can also pass a hex string in that format using the UUID macro. And once you pass it, you can just print it back out, and it'll be exactly the same. And the last two lines of that code just demonstrate different standards of how to print out. You got the braced version, which just wraps in braces. You'll see this in Visual Studio, solution files and projects if you use that, and you can also do it on the EARN IDs, which EARN is, I think, Universal Resource something. I can't remember what it stands for, but it's another standard. Okay, crate number 5, Rand. It provides a random number generator, and you can shuffle a collection, and you can also choose random values over a range. And I missed the S after values there. Poor grammar, I'm sorry. So the simple interface is you can just use random, and if it needs the actual type, you just add it as using a turbofish at the end. If the type's already known, you don't even need that. So you just generate a random. So a random bool will just generate randomly 50-50 true or false. Random U8 will just randomly generate a number from 0 to 255 with uniform distribution. But we can go a bit more sophisticated. We can create a random number generator using the thread_RNG function, and then we can use it to call. We can call the gen function, which pretty much acts like the random function. So here we're generating a random between 0 and 1. That's what happens if you use the F64 or the F32 type. And as the name implies, you can't use this across threads. But we can also use randomness to cross collections and slices. So in the shuffling section there, on the first line, I'm just creating a vector of numbers from 1 to 6. Then I just print in the dice faces, but then I decide I want to shuffle the dice. So I call shuffle on dice and pass in the random number generator, which needs to be mutable because the state of the RNG will change every time you generate a random number. And there will be just produce another vector of 1 to 6, but in some random order. But you can also decide to choose from a collection. So given the dice, if I want to roll a dice, for example, I want to choose a number from one of the 6 I've got in my vector, I can use the choose method and again pass that RNG number, unwrap it because it will return an option, because if you have an empty collection, then it will return none because you can't choose anything from an empty collection. Okay, crate number 6, bitflags. It's used for creating C-style bitmask flags. Enums in Rust are very different from C and C++ enums, and for good reason. And I love Rust enums, but occasionally, if you just want to have bitmask flags for low-level stuff where you're talking to the hardware, especially embedded programming, and bitflags allows you to set this up in a reasonably friendly way. It's type safe, and it can also be used for creating wrappers around C APIs. So let's have an example of how we use bitflags. We use the macro, and it takes this format. We use struct, and we pass the size, and we do a bunch of consts. A is just 1 bit, the first bit, B is the second bit, and C is the third bit in this example. But we can also combine. The macro will parse this and understand this, and it will generate the ABC to combine in terms of OR. So ABC should end up being 111 in binary there. Okay, once we got this, we can do various expressions on it in our code as well. For example, we can unionize bit flags. So here we have E1 is both A and C, and E2 is both B and C. And if we OR E1 and E2 together, we're going to get A, B, and C. And it's going to match the constant we defined for A, B, C. Also like an intersection where we say, okay, we want only the bits that are in both, use the AND operator. And there we can see that when we intersect that, we just get the flag C. We can do a set difference, which basically means, okay, here's the bits that I want, and I want to subtract these other bits. And so in this example, E1 minus E2 will provide just flags A, because the set of A and C, we remove B, which doesn't exist, and remove C, so we're just left with A there. And set complement essentially figures out all the flags that isn't in the set that you give it. And there are other features in this. We got access to the bits using the .bits field, and we can set that to 0. We can set it to some predefined value if you want to. There's debug trait support, so you get nice little messages if you use debug printing. There's also support for pub for visibility inside the macro, so you can have private bit flags which don't appear outside your module. And it also supports repr C and repr transparent, which is useful for interfacing with C. And it also it supports derivation for default. So if you derive default, you essentially get a default method that sets all the flags to 0. And there's a lot more. So again, have a look at the other documentation to see what else you can do. All right, crate 7, Tinyvec. Now, Tinyvec is kind of an optimization crate. It's for providing a stack-based vector for small arrays. So usually Vec you stores just a pointer and a size and a capacity on the stack, but the actual contents of the vector is then allocated on a heap. So whenever you create a vector and put something in it, there's a heap allocation. When you fill up a vector, that heap allocation has to grow. So that's a little bit expensive compared to just using the stack. So this crate provides a stack-based vector for very small arrays. And if the array grows too big, it will either, depending on how you use it, will fall back to becoming a normal vector, in which case it will use the heap, or will just panic. And as I said, it's more efficient because heap allocation is then avoided. So the first type it gives you is ArrayVec. And ArrayVec just uses an array back storage. That's a normal Rust array. So you say, okay, I'm going to provide you 16 I32s. And so that becomes the capacity of the array. The array is empty initially, so you can push up to 16 values into the array before you can panic. So you create it by using a macro, which is shown down the bottom. So in this case, we're creating an array vec with a capacity of 4, but initialized with 3 items. Also, the slice vec. So it is similar to array vec, but uses a slice as the backend rather than a collection, rather than the normal array. So you can construct a normal array. For example, let's let ARR equal 1, 2, 3, 4 and 0, 0, and then we can use the from slice len method to point the vector at that array as a backend store, and we say, okay, we're going to set it initially to 4 in length. So you'll create an array with 1, 2, 3, 4 in it, but it's for space for 2 more. And then finally, there's Tinyvec, which brings some of those together. So this is only available when you have the ad hoc feature enabled. But essentially, when you start using it, it only uses ArrayVec as its backend. So as you fill up that, as soon as the ArrayVec is full, and before it would panic normally, Tinyvec would then switch to a vec implementation. And so instead of panicking during overflow, it will just grow as normal on the heap. So it'll be exactly like a normal vec. All right, crate number 8, DIRS. So this is very useful for cross-platform programming. Whenever you want to save a configuration file for your application, whether you're creating documents for the user, all that kind of stuff. Essentially, each operating system, Linux, Mac OS, Windows, has a set of standard directories where they put standard types of information. So certain directories are used for configuration, certain directories are used for documents, pictures, audio, etc., etc. So this crate allows you to query those folders, find out what they are for any given system that you're running on. So for example, we call config_dir, and that will provide us with the configuration directory for your given operating system. So for on Linux, it will use the xg config home environment variable, or if it can't find that, it will use home/.config. On Windows, it uses the app data environment variable. For Mac OS, it uses application support in the library folder in your home directory. And at the bottom, I provide examples of the different paths that this function will return. But there are many, many directories. There's one for cache directory, config directory, data directory, desktop directory, download directory. There's many, many more. So check out the docs.rs to find out which ones you have. Okay, crate number 9, itertools. So the standard library has an iterator trait and has many methods defined on that iterator trait to do various things like mapping, filtering, and so forth. And it's really powerful and it's really useful. But there are a lot of functionality that's just missing. So itertools attempts to provide some of that functionality and essentially expands the iterator trait with more methods. So there's tons of methods. So there's methods that do chaining. So that's when you take two iterators and put them one after the other. So when you finish iterating through the first one, it starts iterating through the second one. There's filtering, such as all or any. There's zipping, which it takes multiple iterators and then takes each element from each iterator at the same time and gives it back to you as a tuple. And of course, if the iterators are not of equal length, then it will panic. There's merging, so you can take two iterators and then iterate through them, either of them, according to a sort function. So it will choose the next one from either iterator, depending on which is next, according to that sort function. There's sorting, where you can just give an iterator, it will return the next one in sorting. So if you got a mixed iterator, but you want in alphabetical order, you can use this to do that. There's peeking, so you can iterate and look ahead and not change the advancing base iterator. So it's useful for parsing, maybe. There's interleaving, where you get to alternate between different iterators. There's partitioning, where you pass a function across your iterator, and if it's true, then those are given first, and if it returns false, then those are put at the end. There's joining and many, many more. Crate number 10, anyhow. So anyhow provides a simpler error handling experience in your code. It uses a couple of types. It uses an error type you can use in a normal result, or you can use its version of the result itself. And it's basically to accept multiple error types. Now, the usual way to accept multiple error types in Rust is very verbose. It involves having a box that contains the implementation of the error trait plus send plus sync plus the static lifetime, and it's a big, horrible, awful thing to type in your code. With anyhow, you're basically saying, okay, I'm going to return a value. This function may fail, and the error can come from any different kinds of sources. It's not any particular error type. And so the use of the question mark operator can be used freely. You don't have to worry that the result, the error within your result, matches the return type on your function. And you can use this error crate, which I showed in the image viewer talk I did before, how to create error types that implement the error trait. So anyhow only works for error types that implement the error trait. So here's an anyhow example. Here I'm using the anyhow result to pass a string. I read a file and reading into a string. So f is now a string. And if that fails, I can just use question mark, and that will fail with an IO error. But I also can pass it through my own function, say transform string. And if that might fail with a completely different error type, but again, I can just use question mark. I don't need to convert or do any kind of matching or anything like that. And of course, if I get to the end, I just OK it. But I can also add context. So context are just extra information that are used to give to the error object as it's failing. So, for example, I could replace that reading to string with a dot context failed to read files. So if that had failed, then the error object that any error created that would have wrapped the IO error would have all extra information with that string. So eventually, anyhow, will filter out of the main, and you can just print out all that information. Again, the question mark can just handle that. But we can also, the trouble with the context that if you want some sort of process to generate that string, it will run that every single time you call that function, irregardless of whether you failed or didn't fail. So if that is doing too much computation for you, it could be concatenating strings or generating something, then you can use with context, which allows you to pass in a closure. And so that closure is not run at all if everything goes well. Once you have the error, you can and you expect it to be a particular kind of error, you can attempt to downcast it and essentially cast it to your original error. So here, I've got an error. I want to convert it to my error, but that could fail because maybe it isn't my error, and so you'll either get none if it fails, or you'll get some. And so here I use the let command to destructure that for me. And I can, if I'm not interested in creating my own error type, bringing in this error, implementing the error trade, I can ask anyhow to just create a one-off error, which is essentially a formatted string. You can use anyhow to generate that error object, and then you can pass it into the EIR enum. Or I can use bail, and bail will do that and return it at the same time. Okay, just a few more crates left. So crate number 11 is tap. Now, a lot of people don't know about this crate, but it's a little utility crate. It's just for convenience, and it allows functions to provide side effects in expressions. So it can take a value, it will send that to the function, and then return that same value. So essentially, you can insert it in the middle of a chain. So if you want to say log something while that chain is being called, it's just convenient to put that tap in. You don't have to break it off into separate variables. So for example, before I use tap, I let v equal make value, but because I want to log what make value returns, I have to now put into an intermediate variable. So here I use info and I print out what v is, and then I want to continue. So now I want to process the value. So using tap, I can just do make value dot tap dot process value, and I pass in a closure that takes the value that came out of make value, and here I can just call info. And there's also a tap mute as well for if you want to mutate the value as it's going through, maybe uppercase it or something. It's up to you. There's also a piping functionality in this crate, and so here I have a couple of structures, T1 and T2, and I have a function. So I got one function 1 that starts it off, returns a T1, but then I have a function F2 that takes that T1 and then processes it and then produces a different type at the end. So if I would use this normally, I would have to do F2 of F1. And so understanding the code, I have to start in the middle and I read outwards to understand exactly what type of value X is going to be. But you cannot do f1 dot f2 because f2 is not a method. It's just a normal function. So tap allows you to use this pipe method, which you can use to use a suffix form of function calling. So you can read it from left to right. So the f2 f1 becomes f1 dot pipe f2. Of course, the f2 has to have a single argument that take of type that f1 returns for it to work. It's all type safe. But because the input value is moved into the pipe, you cannot return a value whose lifetime depends on the input value. So there's a little bit of constraint there. Okay, crate number 12, Rayon. This is one of the most magical crates in Rust. It allows you to do some really insane stuff with very little effort. Those are the best kind of crates. So it's a replacement for Iterator trait to do iterations in parallel using the work stealing runtime. So essentially, Rayon sets up this thread pool, and when you iterate through stuff normally, it's done on a single thread. With Rayon, by changing how you generate the iterator, all that work when you iterate and you map, when you filter, etc., will get done on multiple cores. You'll instantly, for no work at all, make your program run much, much faster. And it implements many iterative methods that will now work in parallel. So filter will work in parallel, map will work in parallel, and so on. So let's look at an example. So here's the original. We take some input, we run it through iter to get an iterator, and then we map it through some function that processes the input, and then maybe we want to sum it at the end. So we've got an iterator of values, and we end up with a single value. We can make it parallel and make that map run on multiple cores at the same time, literally by changing that iter call to par_iter. It really is that easy. And there's lots of advanced usages as well. There's a full-blown thread pool work stealing engine in Rayon. And you can do things like join, where you run two closures in parallel. And when those closures are finished processing, you can then block until they're both done and then continue. You can spawn a task. So essentially, it would just queue it onto one of his worker threads. You can even use scope, which provides a scope to spawn threads. So usually when you spawn a thread, you can't move any values from the function that spawns it because of lifetime issues. The function on the thread might outlast the function that you're calling. What scope allows you to do is allow you to a scope where you can spawn threads which can take those values, but the scope will block your function and ensure that the function's lifetime is longer than the spawned tasks that you've created. And there's a function called broadcast, which can run a function on every single thread, and then it will collect up all the results and return it as a vector. So quite some nice, powerful multi-threaded tooling there. And of course, being Rust, you're not worried about race conditions because you've got fearless concurrency, as we all know. Right, last crate, number 13, is colored. And it's for helping to output colored text. I love adding colored text to my textual output in my command line. So if I want to create a warning or an error, I can nice to see it in red or something. And this makes this almost trivial. So it works by wrapping strings of the ANSI color codes required by terminals to actually output that colored text. So for example, if I want to print the sentence Cymru am byth in red, white, and green, this is exactly how I do it. By passing a string and calling the method red, it will wrap it with the ANSI color codes that set the terminal to red. And there's a whole bunch of colors. So for the foreground, you've got black, red, green, yellow, blue, magenta, or purple, cyan, and white. So those are your primary and secondary colors. On the background, you just prefix it with on underscore. So for example, on red. For a bright foreground, you just prefix with bright, such as bright red. And for bright backgrounds, you can prefix with on bright. So you get on bright red. And you can change those calls. So you can say, if you want red on a yellow background, you can say .red, .on yellow, for example. There's some other effects. You can use true color to do 24-bit colors. And you can use certain styles such as bold, underline, italic, dim, reverse, blink, hidden, and strike through the complete set there. And so a couple of meta commands which pretty much do the same thing. They just reset the colors. And that's it. So there's a ton of crates, and there's a bunch of large crates as well, which each one can literally take an entire talk to talk about. And maybe it will provide some sort of inspiration for someone to take one of these crates, research it, use it, and give us a talk back about how to use it. The ones that I know of, such as tracing, which is a bit like log, but you can use structured login, so you store structures in there and so forth. Criterion is a benchmark crate for timing all your routines. SerDes is a serialization deserialization crate, very powerful, allows you to convert your internal structures into various formats, binary formats, JSON, RON, etc., etc. NOM is a really, really cool parsing library, pretty much due to parse anything when you're parsing text or binary. I would recommend that everyone learns that one. Tokyo is a full-blown async runtime for doing crazy things over multiple cores. Rocket, Axum, Warp, and Actix are all different web servers, all very powerful in their own way. SynQuote, two famous crates for implementing macros. We got Bevy. You can do so many talks on Bevy. Bevy is a full-blown game engine with an extremely powerful ECS system. And you got Crossterm, which is a cross-platform text to terminal kind of library, so you can just print on the screen, move the cursor around, and so forth. If you feel like writing your own Vim, you probably use Crossterm for that. And TUI is a sort of in medium mode GUI system built on top of Crossterm to actually implement interesting user interface-based terminal applications. And there's hundreds, maybe I should say thousands more. So my best advice to you, if you want to see what's out there, take your favorite crate and then have a look at what its dependencies are, and just follow that rabbit hole, and you'll learn an awful lot. So that's my talk. I hope it was slightly informative. I hope you heard about things that you haven't heard before. And I give you opportunity now to ask any questions. I'm sorry, I didn't read the text on the meeting chat because I was too focused on my talk. So perhaps I can go through the chat now and find out. Oh,
that was great, Matt. I'm sure all of us have come away with a new crate to Google.
Someone said, presumably that let statement will only compile if you add an else. No, that's not true. That's a destruction let. No, you're right. I think you are right. No,
yeah, because otherwise it would fail. Yeah. Because it has to match the none case somewhere. Otherwise, what would it do?
Yeah, you're right. And I apologize.
Sorry, nitpick.
I owe you another drink for that mistake.
I like this new rule. For every mistake, there's a drink owed.
Yeah.
That's the minimum. That's the minimum. If you're going to call someone out and say they're wrong and you end up being wrong yourself, at the very least, you should buy them a drink.
I found a problem while using the colored crate. I don't know if there is a function for it, but basically when you have a number instead of string, right, it becomes hard because you have to use format and then you're going to allocate a new string. Otherwise, you can just use like NC sequence, right, or NC escape codes, right, and you don't have to allocate anything really. It will do everything for you, like in the format itself. So, but I'm not sure there is a function for it.
Is that a crate you're talking about?
Yeah, the colored crate. So instead of passing strings, when you pass numbers and you expect the string to actually format, like to convert your number and format it into the string, how you can color it, because it's not a string, right? I used the format macro, which again allocates a new string, and that new string will go to another format, right, of print line, which is going to allocate another string, which I found quite weird. But instead, the solution, you can just use like a crate that gives you like NC escape codes, and then you can put the NC escape code of a color before the format curly braces, and after the receipt escape code.
Yes, there definitely are crates that will do that. That's for sure. I don't usually have that use case, so I use colored more often than anything else. I usually just to print text to the screen on a command line tool. But yes, I I just had to pick some crates, and now the one I picked, you are absolutely right. There are different, there are quite a few crates for doing ANSY's color sequences with different types of interfaces.
And about Rayon, I want to share with you the fact that it's like I was coding it's like a pixel shader kind of thing using the CPU, right? So I have 12 logical cores, and with the right setup, you can go from single-threaded to multi-threaded just by adding par. That's it. It's like,
yes.
Instead of processing using one logical core, the whole buffer, the whole screen, right now you're using 12 logical cores magically just by adding that par.
It's insanely powerful, and it's a superpower of Rust specifically because you know if it compiles, you're not going to get a race condition, and the way that.
Although I need to set up some things before it's able. For example, I had a vector, a buffer that I was displaying on the window. And by the way, I didn't use pixels or mini FB. So there's pixels, mini FB, and I found a new one called soft buffer. So mini FB is the not standard, but popular, really popular for such a case where you have a buffer and you want to put it in a window.
Mm-hmm.
But mini FB gives you also its own way to actually create a window, which is not really good. There's a lot of cool windowing crates like Winit. So there is soft buffer, which is a new crate that does kind of the same thing, but it uses a crate called raw window handle. So basically,
raw window handle is what Winit uses. Yeah. So Winit provides a raw window handle, and that's the crate that underpins stuff. And other crates such as WGPU and Glium will expect a raw window handle as well. So that's why they interoperate with Winit. So if MiniFP doesn't provide a raw window handle, then that's problematic because it ultimately makes it incompatible with some of the other support crates that do nice things with Windows.
That's why I use soft buffer. And there's also Pixels, which is also good, but it also uses the GPUs. If you really want to go software rendering only, then you cannot use it because it doesn't fall back into software rendering. And for the setup, And for the setup, I just got a vector and I splitted it using the Iterator chunks mutable. And I splitted it into how much threads I have. And that's basically it. Now I can just easily change between par and normal iter. So
I think the chunks is not on the iterator, is it? I think it's on the actual slice.
Yeah, exactly.
So you chunks. This is what I follow this all the time. When I look for the chunks thing on a vector, I can never find it, and then I remember much later that if I just take a reference to that vector and turn it into a slice, then I can find the chunks method for that.
Yeah, it's really useful.
It is really useful. I use it all the time. Any other questions? Don't be shy.
Go on then. What's your favorite out of those 13, Matt?
Ooh, let's have a look at what other. I can't remember what 13 I did now. Rayon is pretty magic. I don't get to use Rayon that often. Some of my favorite crates I didn't explain in this talk, but I use it in the Rust image view talk I did earlier, such as Winit, which is cross-platform. That's amazing. And what else? I love pixels because it just allows me to just play with pixels easily. Yes, so but Serde as well. That's something I use over and over and over again. And Clap.
Serde's magic, isn't it?
And Clap is another one. Whenever I do any sort of command line tool, if it takes arguments from the command line, I will always use Clap. There's just no reason to use anything else. It becomes a standard. You get some nice things out of the box, like help and so forth, and it's just you can create some real professional command line interfaces using Clap.
That's pretty consistent. Oh, sorry.
Just go on. Just go on.
I was just going to say that message of, just use clap is just, I've heard that so consistently across other Rust devs as well. I think it's almost like a de facto standard at this point, isn't it?
It is. Clap, SerDes, those are two really de facto. You don't use anything else. If you use a multi-threader, you want to use Tokyo, for example. You really don't want to use anything else. And that's great because your crates that we can trust, that it encourages a lot of development into and strengthens the ecosystem of Rust. I'd rather have a few really solid, amazing crates than a ton of flaky crates that do things with bad interfaces,
I also found some really cool crates like recently. There is, for example, fast eval, which allows you to calculate expressions really fast. Like, I think it's the fastest expression evaluator right there, out there, right? I think if you allow, turned on all the optimizations, you can go to half the speed of Rust, like half the speed of native Rust. It's a string being evaluated. Of course, you have to compile it first. Then, for example, inside a loop, you can just keep on evaluating it. It's like almost half the speed of native Rust, which is really useful. That's the first one. There's also a second one, which is Chomsky, which is a parser. It's like you can use it to make parsers. It's like I had to look into num, but it looks so confusing and hard, at least for my beginner's brain. But Chomsky looked really familiar, really intuitive in some sense, and it's really easy to
spelled Chumsky.
Yeah, it's probably named after Noah Chomsky, who was a big language processing guy.
So I've just looked up the crate, and you know who the author is, don't you? It's Josh, who gave us the Valoran talk a few weeks ago. It's one of his. Cool. just Googled it. I was like, this has happened to me a number of times now, where I'm just like, oh, I'll check out this crate somebody recommended me, and it's his. It just keeps happening. Sorry, man. Carry on.
So I used.
It's quite nice, yeah.
So I used Rayon with fast eval to create like a pixel shader where you have a CLI, then you can pass just an expression, the width and the height of the image, and then it goes ahead and use Rayon for multi-threading, and it goes on every pixel and it evaluates that expression. Of course, that expression is compiled before entering the loop, and then you just keep on evaluating it inside the whole loop because you're gonna have 2 billion pixels or even more. So it's really amazing.
Yeah, there's a very famous algorithm written by Dijkstra, Edgar Dijkstra, the same guy who said go-tos are evil. I forget what it's called. It's something to do with railway. Chantignard, right? The Chantignard, the Chantignard algorithm. Yeah. And I've used that myself for implementing expression parsers in assemblers. And it's very, very simple. It's one of the genius algorithms. It's up there with red-black trees, and I think it's amazing, and it's just so simple, and you can define operator precedence and things like that really easily.
You can use enum, by the way, like the order of enums. You can use it for precedence if you don't know already. I just recently knew about that, which was so cool.
I don't know what the crate you're talking about, but it was.
No, it's not a crate. I guess it's just a normal enum, and maybe you define partial EQ or something like that. I don't know. I don't really remember, but I've seen it in a video. I can send you the video later on. It's quite nice. Mm-hmm. It's about Chantignard algorithm. Basically takes an infix expression, and then it turns it into an RPN, reverse Polish notation. And then reverse Polish notation is really simple to evaluate using a computer, right? Because you go from left to right and no precedence.
that's what I suspect it does. It uses a shunting yarn algorithm to generate that RPN expression, which is your pre-compiling stage, as such. So when you want to evaluate it again, you just run through that, and it's just straightforward.
Okay. It's also using a really interesting thing, which is it's not allocating at like a lot of little chunks. It's using a slab kind of data structure, right? It's just allocating one big chunk and then it's just reusing it.
Well, the shunting yarn algorithm uses a couple of queues. It uses a stack and a queue to generate the final reverse Polish notation expression. I recommend, if you're interested in algorithms, to read up on it. I did do a blog on it on how I use it for my expression evaluator. Maybe I'll dig that up sometime. But it's not related to Rust, that blog at all.
Yeah.
Okay. Any more questions? If not, then I'll end the talk.
Sounds good. All right. Thank you very much for that. And thank you everyone for coming along. And just a reminder, we're looking to fill out the calendar for next year for other talks. So as always, if you're interested in giving a talk, please let us know, drop us a message in the Discord. You don't have to be an expert matter in the subject. We're quite happy to have people of all skill levels talking. It doesn't always have to be entirely technical as well. It could be, I decided to learn this project or try this out, and here's what happened. We're just generally a group of people who are interested to learn at all levels. So please do put yourself forward. It's a lot of fun, actually. It's really rewarding. It really encourages you to go out and learn some stuff to get some good information out there. I'm sure Matt will tell you just how much fun it's been.
Oh, I agree with that.
Thank you for the talk, by the way.
I didn't know all those crates intimately. I have used about half of them, which is why I struggled with Alex's question about which is my favorite one. But I knew that the other half, the ones I didn't use, were pretty popular and used everywhere. And so I took the time to actually look into them, and I learned more. And so, if, for example, if you fancy giving a talk on, let's say, Bevy engine, then go away, play with it, and have fun, and then come back and give us a talk. I know I would like to listen. Hint, hint.
Right then. Well, if there's nothing else, we'll see you all next time. Thanks again, Matt.
Bye.
Take care, guys.
Bye, everyone.